Use RESTCONF to access an iOS XE router. This is the topology. A PC with CCNP virtual machine. The switch is optional and a router with iOS XE. But I will use a sandbox router on the cloud. The addressing table with interface and IP address on the device, the PC. The RESTCONF protocol is a subset of netconf. RESTCONF allows you to make RESTful API calls to an iOS XE device. The data that is returned by the API can be either XML or JSON. In the first half of this lab, you will use the Postman program to construct and send API requests to RESTCONF service that is running on the router. In the second half of the lab, you will create Python scripts to perform the same task as your Postman program. The required resources: one router. I will use a sandbox router on internet on the cloud. Switch is optional. One PC with CCNP virtual machine. Build a network and verify connectivity. You will cable the devices, start the CCNP virtual machine, configure the router for netconf and RESTCONF access over an SSH connection. You will then verify connectivity between the CCNP virtual machine and router and test an SSH connection to router. Cable the network ready, start the CCNP virtual machine. If you have not completed lab, install the CCNP virtual machine. Do so now before continuing with this lab. Open VirtualBox, start CCNP virtual machine. VirtualBox. And this is CCNP virtual machine. Go to settings, go to network, verify. You can choose bridged adapter to connect the real network. This is the physical interface. In my case, a gigabit interface. On advanced, be sure cable is connected. Otherwise, you can choose NAT, will work very good. Okay. And start. Ready. Enter the password student pass, case sensitive, to log into the virtual machine if prompt. Configure R1, connect to the console of the router and configure basic settings for the lab. Okay, you need to copy and paste this to the router, but the router that I will use is the sandbox router on internet. So this is not necessary because the sandbox router is already configured. Verify the CCNP virtual machine can ping the default gateway. In the CCNP virtual machine, open a terminal. Okay. Click here to open a terminal. Okay, verify the IP address on the virtual machine. IP address 192.168.165. Okay, Verify you have a valid IP address. May vary in your case. This is my IP address, is very good. Also IPv6. But at least you need an IPv4 address. Ping 192.168.1.1. Ping the IP address of the router. The destination is 192.168.1.1 because the gigabit interface on the router is 192.168.1.1. But I will use the sandbox router. Go to developer.cisco.com. Login. You can log in with Google. Here you can choose DevNet resources. Sandbox. Get started with sandbox. And on regular you can choose iOS XE on CSR latest code version 17.3.1 to reserve. Or you can use always on. You can use iOS XE on CSR latest code version 17.3.1 or iOS XE on CSR recommended code version 16.93. Okay, I will use this version 17.3.1 iOS XE on CSR latest code. Click here. Okay, this is the device, iOS XE on CSR latest code, version 17.3.1. Access details, the name, sandbox-iOS-XE-latest-1.cisco.com, SSH port 22, netconf port 830, RESTCONF port 443, HTTPS, username, developer, password, C1SEO12345, fields C uppercase, be careful, case sensitive, and ping the device. Virtual machine, ping. In this case, I will use this name, this sandbox iOS XE latest-1.cisco.com. Enter. This is the IP address of the device. Ping is not working. Control C to stop this process. Control C. 15 packets transmitted, 0 received, 100% packet loss. Okay, ping will not work because the router is blocking pings. This is for security and for availability, and don't worry about this. If the CCNP virtual machine has not received IPv4 addressing, check your physical connections, verify that R1 is configured correctly, establish an SSH connection to R1, open PuTTY SSH client, enter the IPv4 address for the router, open. Okay, this is PuTTY. Okay, this is PuTTY. Use the name use the name for the router, copy, paste, port 22 SSH, open. Okay, the username for the lab is the username Cisco and password Cisco123 exclamation mark. But in my case, it's different for the sandbox router. The username is developer and password C1 SCO12345 C uppercase. Developer C1 SCO12345 enter. Very good. Okay, but this is very small. Close this. Are you sure? Yes. Okay, configure an iOS XE device for RESTCONF access. You will configure router to accept RESTCONF messages. You will also start the HTTPS service on the router. Verify that RESTCONF is running on R1. RESTCONF may already be running if another student enabled it, or if a later iOS version enables it by default. From SSH, you can use show platform software yang management process command to see if all the daemons associated with the RESTCONF service are running. Okay, on virtual machine, right-click on terminal and open a new terminal. Okay, I prefer to use the terminal for the SSH connection. I will not use PuTTY, but it's the same process. Okay, SSH developer is the username and the name of the router. Okay, SSH, the username, the name, and the password C1 SCO12345 enter. Very nice. You are on the router. Use the following command: show platform software yang management process enter. Okay, software enter. Okay, confd should be running, nest should be running, sencfd running, dmi outd running, ndb mand running, pubd running. Very good. The purpose and function of all the daemons is beyond the scope of this course. Enable and verify RESTCONF service. Enter the global configuration command RESTCONF to enable the RESTCONF service on R1. Okay, use RESTCONF if some processes, if some daemons are not running. Use this command on global configuration mode RESTCONF. Verify. Recall that NCSSHD is the netconf service which may be running on your device. We do not need it for this lab. However, you do need Nginx, which is the HTTPS server. This will allow you to make REST API calls to the RESTCONF service. Okay, you can verify again, and Nginx should be running, but if it's not running, enable and verify HTTPS service, Enter the following global configuration commands to enable the HTTPS server and specify that the server authentication should use the local database. Configure terminal on global configuration mode, IP HTTP secure server, and IP HTTP authentication local to use the local username and password for the authentication on HTTP. Then verify, show platform software Nginx management process and Nginx should be running. Okay, in my case, Nginx is running. But if it's not running, use these commands to enable the service. Open and configure Postman. You will open Postman, disable SSL certificates, and explore the user interface. Open Postman on the virtual machine Postman application. Okay, click here on Postman. Here, Postman. The first time you open Postman, it will ask you to create an account or sign in. At the bottom of the window, you can also click the skip message to skip signing in. Signing in is not required to use this application. Disable SSL certification verification. By default, Postman has SSL certification verification turned on. You will not be using SSL certificates with the router. Therefore, you need to turn off this feature. File settings. Under General tab, set SSL certificates verification to off. Close the settings. Okay, on File, Settings, SSL certificate verification off, and close this. Use Postman to send GET requests. You will use Postman to send a GET request to the router to verify that you can connect the RESTCONF service. Explore the Postman user interface. In the sender, you will see the launchpad. You can explore this area if you wish. Click the plus sign next to the Launchpad tab to open a Get Untitled request. This interface is where you will do all of your work in this lab. Okay, here in the middle, click here, the plus sign, click here. Okay, Get Untitled request. Enter the URL for the router. The request type is already set to GET. Leave the request type set to GET. Okay, is actually GET. Enter the URL field, type in the URL that will be used to access the RESTCONF service that is running on R1. The HTTPS : the IP address and RESTCONF. HTTPS : The name, in my case, is not an IP address, it's a name. sandbox-isxe-latest-1.cisco.com / RESTCONF. Enter authentication credentials. Under the URL field, there are tabs listed for params, authorization headers, body, pre-request, script, and test. In this lab, you will use authorization headers and body. Click Authorization tab. Click here, Authorization. Okay, params, authorization headers, body, pre-request, script, test, settings, authorization. Click the down arrow next. Okay. Inherit authorization from parent. Choose basic authentication. Inherit authorization from parent. Choose basic authentication. Basic authentication. For username and password, enter the local authentication credentials on R1. Okay, this is the username. Enter developer. Okay, and password C1 SCO 1 2 3 4 5. C1 SCO 1 2 3 4 5. Add authentication credentials to the request headers. Click headers, then expand the temporary headers field. You can verify that the authorization keys has a basic value that will be used to authenticate the request when it is sent to the router. Okay, go to headers. Okay, 8 hidden. Click here, 8 hidden. And you can see the authorization is basic. Set JSON is the data type to send and receive from the router. You can send and receive data from the router in XML or JSON format. For this lab, you will use JSON. Above the temporary headers area is the headers area. Click the key field. Hide auto-generated headers. Hide. And on key, type content type for the type of the key. It is case sensitive content type. The value is application yang data JSON. Okay, value application slash yang dash data plus JSON. Okay, plus JSON. This tells Postman to send JSON data to R1. Below your content type key, add another key value pair. The key field is accept and the value field is application yang data JSON. Okay, down here in key accept value is the same, like this. Copy, paste, it is the same. You can change application yang data JSON to application yang data XML to send and receive XML data instead of JSON data if necessary. Send the API request to R1. Postman now has all the information it needs to send the GET request. Click Send. Below temporary headers, you should see the following JSON response from R1. If not, verify that you complete the previous step in this part of the lab and correctly configure SSH in part 1 and RESTCONF in part 2. Okay, this. Okay, and click Send. Okay, send. This is the response. Okay, this JSON response verifies that Postman can now send other REST API requests to R1. Use GET request to gather the information for all interfaces on the router. Now that you have successful GET requests, you can use it as a template for additional requests. At the top Postman, next to the Launchpad tab, right-click the Get tab that you just used and choose Duplicate the current tab. Okay, here on Get request, right-click, Duplicate tab. Use the IETF interfaces Yang model to gather interface information for the URL at data IETF-interfaces column interfaces. Okay, this is the new URL. Modify. Okay, click here and data IETF-interfaces column interfaces. Click Send. You should see a JSON response from the router that is similar to the output shown below. Your output may be different depending on your particular router. Okay, send. Look at this. The information of interfaces gigabit 1, gigabit 2, gigabit 3, loopback, and so on. Use a GET request to gather information for a specific interface on the router. Okay, duplicate your last GET request. Okay, here I have two. On the second, right-click, duplicate tab. Add the interface equal parameter to specify an interface and type in the name of the interface. However, notice that you need to use the HTML code %2f for the forward slashes in the interface name. So 0/0/1 becomes 0%2f 0%2f1. Okay, use this. But in my case, review the previous tab. Gigabit Ethernet 1 does not have slash or slashes. Gigabit Ethernet 1. Copy this, go to the third tab, and the URL specify the following. Add the following slash interface equal and paste the name of the interface. Okay, the name of the router, RESTCONF, data, IETF interfaces, column interfaces. The interface equal the name of the interface. Send. You should see a JSON response from the router that is similar. Your output may be different depending on your particular router. Okay, send. Okay, this is the response. Only information about Gigabit 1. Okay, and JSON format. Use Postman to send a put request. You will configure Postman to send a put request to R1 to create a new loopback interface. Duplicate and modify the last GET request. For this step, use loopback interface information that was assigned to you by your instructor. If you were not assigned a loopback information and no other students are accessing your router at the same time as you, then you can use loopback information specified below. Duplicate the last GET request. Okay, the last right-click, duplicate tab. Very nice. For the type of request, change to put. Okay, it's not GET now. You will use put. For interface, change to loopback 1 to specify a new interface. Okay, on the URL, use loopback 1. But you can use another number because a lot of students are accessing to this sandbox router, and maybe loopback 1 exists, so use a different number. For example, 777. This new loopback 777. Okay, interface equal loopback, and the number you choose. Interface equal loopback and the number. Configure the body of the request specifying the information for the new loopback. To send a put request, you need to provide information for the body of the request. Next to headers tab, click body. Okay, next to headers body, click here. Okay, body. Click raw radio button. Okay, click here raw data. The field is currently empty. If you click send, you will get error code 400 bad requests because loopback does not exist yet and you did not provide enough information to create the interface. Replace the text in brackets in the description field with your name. Remove the brackets. This will add your name to the interface description. Fill in the body section with the required JSON data to create a new loopback interface. You can copy the body section of the previous GET request and modify it. Or you can copy the following into the body section of your PUT request. Notice that the type of interface must be set to software loopback. Okay, you can copy and paste this for the body. Okay, here. Or go to the previous tab and copy this information about the gigabit interface of the previous result of the previous response. Your PUT tab here on body raw, right click paste. But change this is not gigabit interface, is loopback 777 in my case. Copy, paste. The description, you can use your name, okay, and interface type, use software loopback. Software loopback, case sensitive. Case sensitive. Okay, it should be software loopback, case sensitive, L uppercase. L uppercase. IAANA, interface type, software loopback. Enable true. IPv4 address. Choose a non-existent IP address because if you will duplicate the IP address of an existing interface, you will get an error. So choose the following, for example, 10777. Okay, and the net mask, use for example this 255, 255, 255, 255. No information for IPv6 and review. Very nice, name, description, type, enable, address, IP net mask. Very good. Send. In the response field, you should get 201 created HTTP response code. This indicates that the source was created successfully. Okay, send. You can see 201 created. Very good. You can verify that the interface was created by entering show IP interface brief on the router. You can also run the Postman tab that contains the request to get information about the interfaces on R1. Show IP interface brief. Okay, here. This window. On this terminal, enter, Control C. Okay. I was disconnected by the SSH timeout, so close this. Close terminal, right click on terminal, new terminal. Up arrow to repeat the SSH and username developer, the name, enter. Password C1SCO12345, enter. Show IP interface brief. You can see loopback 777 with the IP address, status app, protocol app. Very nice. Use a Python script to send GET requests. Import modules and disable SSL warnings. Open IDLE, file, new file. Okay, this is IDLE. Click on File, New File. Save file as RESTCONF-get.py. Save as on home student directory. RESTCONF-get.py. RESTCONF-get.py. Save. You can verify the name up here. Enter the following commands to import the modules that are required and disable SSL certificate warnings. Okay, I will copy this to a notepad. Okay, copy all this to a notepad. Copy, open the notepad, paste, save. Okay, choose a name, save. Okay, I will use Google Drive to transfer the file to the virtual machine. Okay, this is the file. From virtual machine, open Firefox. Go to drive.google.com. Access. Okay, this is the file. Download. Save file. Okay. Okay, close Firefox. Go to Files. Downloads. Open RESTCONF file. Very nice. Okay, the JSON module, request module, disable warnings. The JSON module includes methods to convert JSON data to Python objects and vice versa. The request module has methods that will let us send REST requests to an URI. Okay, copy these 3 lines, copy, paste here, enter, enter. Create the variables that will be the components of the request. Create a string variable to hold the API endpoint URI and 2 dictionaries, one for the request headers and one for the body JSON. Notice that these are all the same tasks you completed in the Postman application. Create a variable named API URL and assign it the URL that will access the interface information on router. Okay, this line in the text editor, this line API underscore URL. Okay, for interfaces, all the interfaces. Create a dictionary variable name headers that has keys for accept and content type and assign the keys the value application yang data JSON. Okay, the headers, text file, these headers, 3 lines. For headers, enter, enter, paste. Okay, accept application yang data JSON, content type application yang data JSON. Create a Python tuple variable named basic authentication that has 2 keys needed for authentication, username and password. Okay, basic authentication. This basic authentication. Enter, enter. Create a variable to send the request and store the JSON response. Use the variables that were created in the previous step as parameters for the request method. This method sends an HTTP GET request to the RESTCONF API on the router. Assign the result of the request to a variable named resp. That variable will hold the JSON response from the API. If the request is successful, the JSON will contain the return yang data model. Enter the following statement: resp variable. Okay, and this line resp variable, copy, enter, enter, paste. The table below lists the various elements of this statement. Resp, the variable to hold the response from the API. This is resp. Request get, the method that actually makes the GET request. API URL, the variable that holds the URL address string. This is the URL here. Out, the tuple variable created to hold the authentication information. Out, basic authentication is this username and password. Headers equal headers, a parameter that is assigned the headers variable. This verify false disables verification of the SSL certificate when the request is made. Okay, verify false. To see the HTTP response codes, add a print statement. Okay, print resp. At the end, print resp variable. Save and run your script. You should get the output shown below. If not, verify all previous steps in this part as well as the SSH and RESTCONF configuration for the router. Okay, response should be 200. Okay, but review. Import JSON module, import request module, disable warnings, the URL. Here use the name for the sandbox router. You know it's not an IP address, it's a name. Sandbox dash iOS exit dash latest dash one .cisco.com. Sandbox iOS exit latest dash one .cisco.com. RESTCONF data IETF interfaces equal interfaces headers, very nice. Basic authentication, the username is different, is developer, password C1 SEO12345. Okay, the username and password for the sandbox router response. Okay, very nice. And file save, run. Response 200, very good. Format and display the JSON data received from the router. Now the Yang model response value can be extracted from the response JSON. The response JSON is not compatible with Python dictionary and list objects, so it must be converted to Python format. Create a new variable called response JSON and assign the variable response to it. Add the JSON method to convert the JSON. The statement is as follows. This line. And finally, print the statement. Okay. Add this response JSON, copy, enter, paste, and this another print response JSON, copy, enter, paste. Okay, you can do the following. Save and run. You should get output similar to the following. The information of all interfaces. Save. Okay, now you will convert the response output to JSON format and print. Okay, save and run. Okay, response 200, information of interfaces, gigabit 1, gigabit 2, gigabit 3, loopback 777, very nice. To predefine the output, edit your print statement to use the JSON dumps function with the ident parameter. Okay. You can use this. Okay, the text editor. Print JSON dumps response JSON indent for. Enter. Paste. Okay. This is to predefine JSON. So comment this line. Okay, comment this line, the simple response JSON, because you will use the predefine, because you will use the pretty JSON. Save and run. This output is virtually identical to the output of your first Postman GET request. Okay, save and run. Squeeze text 67 lines. Double click here. Now you can see more readable JSON. Gigabit 1, Gigabit 2, Gigabit 3, loopback 105, loopback 777. Compare with Postman, the first or the second response, the same information. Use Python script to send a put request. You will create a Python script to send put request to the router. As was done in Postman, you will create a new loopback interface. Import modules and disable SSL warnings. For this step, use loopback interface information that was assigned to you by your instructor. Okay, use a different number and different IP address. Okay, this is important. Open IDLE, new file. Okay, file, new file. Save the file as RESTCONF put. File, save as home student directory restconf-put.py. restconf-put.py. Save. Enter the following commands to import the modules and disable SSL certificates warnings. Okay, these 3 lines go to text editor, okay, import JSON request and disable warnings, copy, paste, enter. Create the variables that will be the components of the request. Create a string variable to hold the API endpoint URI and 2 dictionaries, one for the request headers and one for the body JSON. Notice that these are all the same tasks you completed in the Postman application. Create the variable name API URL and assign it the URL that targets the new loopback interface. Okay, this line for the API URL. Okay, API URL. Copy, paste. Okay, enter, enter. Create a dictionary variable named headers that has keys for accept and content type, and assign the keys the value application yang data JSON. Okay, 3 lines for headers. These 3 lines. Copy, paste, enter, enter. Create a Python tuple variable named basic out that has 2 values needed for authentication, username and password. Okay, basic out, username and password. Copy, paste, enter, enter. Create a Python dictionary variable yang config that will hold the yang data that is required to create new interface loopback. You can use the same dictionary that you used in part 5 for Postman. However, change the interface number and address. Also be aware that Boolean values must be capitalized in Python. Therefore, make sure that the T is capitalized in the key value pair for enable true. Okay, copy this and my text editor, yang config, copy this. Be careful to copy, paste. Okay, yang config is the variable, and this is the JSON information. If using an apostrophe in the description text string, then you must escape it with the backlash as shown above. Okay? If you will use apostrophe, use backlash before. Create a variable to send the request and store the JSON response. Use the variables created in the previous step as parameters for the request put method. This method sends an HTTP put request to the RESTCONF API. Assign the result of the request to a variable named resp. The variable will hold the JSON response from the API. If the request is successful, the JSON will contain the return yang data model. Before entering statements, please note that this variable specification should be on only one line in your script. Enter the following statements. This variable specification should be on one line in your script. Okay, the response only in one line. The text editor, this response right here, and enter, enter, paste. Okay, very good. Enter, enter. Enter the code below to handle the response. If the response is one of the HTTP success messages, the first statement will be printed. Any other code value is considered an error. The response code and error message will be printed in the event that an error has been detected. Okay, these lines to handle the response. Okay, search this on my text editor. Okay, if here 4 lines. Paste. Okay, review. Okay, very good. Table below lists the various elements of these statements. Resp, the variable that holds the response from the API. Request put, the method that actually makes the put request. Okay, this API URL, the variable that holds the URL address string. This that is this the URL. Data, the data to be sent to the API endpoint, which is formatted as JSON. Data in JSON format. Yang config. Okay, the body. Yang config. Out, the tuple variable created to hold the authentication information. Okay, out, basic out, the username and password. Headers equal headers, a parameter that is assigned the headers variable. Headers equal headers. This verify false, a parameter that disables verification of the SSL certificates when the request is made. Verify false. RESP status code, the HTTP status code in the API put request reply. This RESP status code. Run the script to send the put request to the router. You should get a 201 status created message. If not, check your code and the configuration for the router. Okay, verify this code and review JSON module, request module, disable warnings for SSL, API URL. You know it's not an IP address, it's a name, sandbox-iosxe-latest-1.cisco.com. Be careful with the name. Review. Then RESTCONF data IETF-interfaces column interfaces slash interface equal loopback and set a specific number, for example loopback 888. Okay, a different loopback. I'm using loopback 888 because previously on Postman I created loopback 777. So use a different number. Okay, in this case loopback 888. Okay, very nice. Remember this name and number. Headers, very good. Accept, content type, application data JSON. Basic authentication, you know, is different. Username developer and password C1 CO12345. Username and password. The body is the Yang config variable. IETF-interfaces, interface. Name, loopback, remember 888. Loopback 888 in my case. Description, use your name avoid to use apostrophe. Okay, description, your name, loopback interface. Type IANA interface type software loopback L uppercase. Enable true T uppercase. Be careful here, T uppercase. And the IPv4 address. Use a different address used previously. Okay, use this IP address. A different IP address, use it in Postman. Previously, I used 10.777, but in this case, different IP 10.888. And use this subnet mask 255, 255, 255, 255. Okay. If the IP address exists in the router, you will get an error message. So be sure this IP address is not existing, is not configured on the router. Okay. No information for IPv6. Respond request put. API URL is the URL. The body yang config is this. Authentication is this. Headers this. Verify false. Okay. If response status code is equal or higher than 200 and response status code is lower or equal to 299, print status OK and show the response status code. Otherwise, else print error and print the status code. Okay, this is very good. File. Save and run. Save. Run. Status OK 201. Okay, verify on the router, show IP interface brief. Okay, on this window, on this terminal, enter Control C. Okay. I was disconnected for the SSH timeout. Close this, close terminal, right click on terminal, new terminal. And up arrow to repeat the previous command, SSH developer, sandbox iOS latest 1, cisco.com, enter. Okay, password C1SCO12345, enter. Okay, somebody created a banner and show IP interface brief. Now you can see loopback 8888. Very good. The code is working very good. Okay, programs used in this lab. Okay, very nice. You can remove these loopbacks. Configure terminal, no interface. Loopback 777, no interface. Loopback 888, and verify, show IP interface brief. Very good. Thank you very much.